Find the limit. In our first example, we have the limit as x approaches -3 for the function 4x plus 2. Let me zoom in a little bit more, y'all. There we go. If your function is well defined for the value of x you're approaching, you can directly substitute that value in. 4 times -3 plus 2 is -10. On our second example, we also have a function that's well defined. We're still approaching -3. Polynomials have infinite domain. Once you replace all the x's with -3, make your calculations, you should come up with 7. For the next 3 limits, we also have success with substituting in the approach number, x approaching 7, 3 times 7 plus 2, that does not create a zero denominator. That value comes out to 3/23. Second example, we're approaching +3. 3 plus 1 is 4, has a square root of 2. In the numerator, 4 times 3 is 12. 12 divided by 2 is 6. If your fraction doesn't reduce, that's okay. If it does, please reduce. The example at the bottom, we have the limit as x approaches pi/2 for the function 3 sine x. Sine of x has infinite domain. Therefore, we can directly sub in pi/2 for our x value. 3 times sine of pi/2 is 3 times 1, which is 3. Find the limit. We have 2 functions given. F of x is defined as x plus 2. G of x is defined as x squared. The limit as x approaches -4 for function f is -4 plus 2. That has a value of -2. Function f is well defined with an infinite domain. The second limit as x approaches 2 is for function g. X squared also has infinite domain. You can square any negative, positive, or 0, and you'll get an answer. The function is well defined. 2 squared is 4. In our third example, we have a composition. Remember that composition is when you place one function inside of another. Specifically for g composed of f of x is equal to x plus 2, and function g takes whatever's in the parentheses and squares it. X plus 2, written twice and FOILed, would give you x squared plus 4x plus 4. But since we're simply plugging in values, you can bring this not multiplied out, just leave it grouped and squared. Substitute your -4 in for x. -4 plus 2 is -2, but if you multiply 2 negative 2's together, you will get 4. In our last 2 limits, tangent is defined except for the odd pi/2's. For this one, we're just simply trying to investigate the function value when x approaches pi. Tangent of pi is well defined and it has a value of 0. So 3 times 0 is 0. That's this upper left limit. The second limit, the limit as x approaches 5 pi/6. Again, the sine function has infinite domain, so you can plug in any angle. Sine of 5 pi/6 is equal to 1/2.